Okay, so this is for Algebra 2 here, and this deals with the assignment worksheet 4.3a. So what this deals with is factoring out. So let's do just a quick review. So we've learned how to basically multiply two polynomials, and sometimes even more, where this could be 3 or 4. So like for example, if I have, let's say, x plus 4 and let's say 3x minus 7, that we can create a box, and x plus 4, 3x minus 7, and let me change my color here. So therefore we have 3x squared plus 12x minus 7x minus 28, and 3x squared is that plus 5x minus 28. So now the next question is going the reverse direction. So for example, if I took one of these and I divided out x plus 4, what would that equal? Now obviously if I take this, I'm going to end up with 3x minus 7 if I divide out. Okay, so the question is how we do something like that. All right, so in sense, like I said, if we have, let's look at numbers here. If I go 4 times 5, I get 20. Therefore, if I divide out by 4, I'll get 5. Or if I go 20 divided by 5, I get 4. So this is the concept that we're going to be looking at, how to do that. So one way of doing this is that if I have factors that say x plus 2 and 2x minus 3, if I can factor these out, then I know what I can divide by. So for example, I can go ahead and divide, let's say, by x plus 2, and that would give me 2x minus 3. Okay. Or I can go ahead and, let's say, if I have x plus 2 and 2x minus 3, and if I divide out by, say, 2x minus 3, I'll give you x plus 2. But what would happen if I had something that say x plus 2, 2x minus 3, and I divide out by, let's say, something like, say, x plus 5? Well, now what's going to happen is I'm going to get a remainder here. Kind of like, for example, let's go back to, say, 20 times divided by 4 is 5, but what happens if I go, say, 20 divided by, let's say, 6? Right? Well, what's going to happen is the 6 will go into that 3 times. So basically we're going to be doing long division. So 6 goes 3 times, 18, which gives me 2. Now, a lot of times we put remainders, but that would be mathematically incorrect. So we actually do this. We go to plus 2 over 6. Now you're used to seeing it like 3 remainder of 2. Or maybe 3 and 2, 6. But it's actually written as 3 plus. And when you, obviously you can see that is 3 and 2, 6. Okay, but we're going to have to keep it separate like this. So let's do one more here. So like for example, let's say 20 divided by 7. Okay, that implies, okay, put the 7 on the bottom into 20. So what we're trying to do here is we're trying to multiply 7 by something that comes close to 20. Like, for example, 3, 7 times 3 is 21. Now that's too much. If I go 7 times 2 is 14. That's less than 20. So what we want to do here is multiply by 2 for 14. Now we don't add, so what we do here is we have to change the signs to a negative. So therefore we have 6, and therefore what we do is we put plus 6 over 7. Okay. And let me do one more here just to give you that idea here, because this is how we're going to leave our answer like this. Let's say something different here. So let's say 23 divided by 5. Okay, that would imply, so now you put the 5 on the outside by 23. So if you look at your options, like say 5 times 3 is 15. 5 times 4 is 20. 5 times 5 is 25. Well, the one that comes the closest to 23 is this one here. So we're going to multiply by 4. So we get 20. Now the one thing is we don't add, we change our signs from a positive to a negative. And therefore we have 3. And when we are all done here, this is our remainder. So we go plus 3 over 5. All right. So let's try this with some polynomials now. So I'll leave that there so we can use that as an example. So I have, let's say, x squared plus 8x plus 7. So I'm going to divide this by x plus 7. So what does that imply? Well, I'm going to go ahead and put x plus 7 on the outside. I have x squared plus 8x plus 7. And now I'm going to try to look at this value here. Right? So the most I'm going to multiply here, and I'm going to put an x here. So if I take, let's come over here, x plus 7, and multiply by x, that gives me x squared plus 7x. So this is the number that I'm trying to get, is the first one, not the second one. So what I have here is x squared plus, oops, that's 7x. Now, remember what we did here is we changed the signs. So we got to subtract. So this becomes a negative and a negative. Now if that was a negative, then it becomes a positive. So I just changed my signs. Now I can add. So those cancel out. Here gives me 1x. And now I have one more number here, so I bring that down, plus 7, and then I repeat myself until I run out of values that's in the green here. So, what do you multiply by x plus 7 to get an x? Okay, go back to red here. So, I'm going to multiply by 1. If I multiply by 1, I get x plus 7. This and this number is what I'm trying to get. So I have 1x plus 7. So now I'll change my signs. So this becomes a negative. This becomes a negative, or if it was a minus, becomes positive. Cancel out, and that cancels out, which means there's no remainder here. And I did forget to put my plus 1 up here. Which means these are the two factors of these. Which means that, let's summarize this, that x squared plus 8x plus 7, when I divide it by x plus 7, well, this piece here must be the factors of x plus 7 and x plus 1. So when I divided out x plus 7, it went to it evenly, and I got x plus 1 with no remainder. Okay? Now, let's try another one here. Okay, so let's try 6x squared minus 23x plus 7 over 3x minus 1. All right, so which implies take 3x minus 1 and divide it into 6x squared minus 23x plus 7. All right, so we're looking at this very first number. So let's come over here on the side. What can I do to get a 6 here? And that would be a 2x. So if I multiply that, that gives me 6x squared minus 2x. So notice I got 6x squared and a 6x squared. So let's come over here. I got 6x squared minus 2x. Now we gotta just subtract here. So this becomes a negative. And take a look at this one. Now this becomes a positive. Okay. Now that cancels when I add those two together. And then my next column here gives me negative 21x. So now bring down the plus 7. And now let's take 3x minus 1. Come back to red here. What do I get to get a minus 21x? That would be a negative 7. That'd be negative 21x plus 7. Okay, so it'd be negative 21x plus 7. So I matched it. So now I got to subtract. So this now becomes positive, and this becomes negative. So that cancels, and that cancels, so I get 0. Right? Which means there's no remainder. So let me come back here. So let's come back and put my values in. I should have done that as I went. So I have 2x minus 7 from these two values here. What does that tell me? Oops. So if we look at 6x squared minus 23x plus 7, and I divide it by 3x minus 1, that would mean that this piece here are factors of 3x minus 1 and 2x minus 7. So when I divide it out by 3x minus 1, it canceled, and I got 2x minus 7. So there's no remainder. Okay. All right. Now, we're going to keep this real simple here. We're going to keep the numbers pretty small, but that's basically what we're looking at. Whether or not we can find values that will divide out evenly. So, let's do one more here. So, let's say if you have y plus 4, and I want to divide it into y squared plus 12y plus 32. Okay, so first thing here is let's take y plus 4 and let's see what we can do to get a y squared. Well, if we multiply by y, that will give me y squared plus 4y. Okay, so let's bring that over here. So you have y squared plus 4y. Let's change my sign so that becomes negative and negative. So it cancels out, which is what should happen. This is 8y. Bring the next one down here, plus 32. And now let's take my y plus 4 again and see what we can multiply by to get a 8y. So let me change colors so we can see. So I'm going to multiply by 8. Because if I multiply those two out, I get 8y plus 32. So I have 8y plus 32. And what I have then, let me change my signs here. I haven't used brown yet. Negative, negative, cancels, and cancels. So it goes into evenly. So we got to come back here now. There's my two numbers here. So this would be y plus 8 with no remainder. Okay. Now, like I said, we're going to keep this simple. So there's another way of doing this because we're going to keep these numbers real simple. There's a thing called synthetic division. Let me show that here. So it's synthetic division. Okay. Now what we can do here is actually get rid of my variables. Do the same. I'm doing the same problem up here. So I'm going to go here. Now again, you have to have a 1 here. So it's like completing the square. So if there's not a 1 there, what I have to do is go through and divide out every single one. Now I'm not going to have you do that for a while, but I'm going to give you where every single time there's a 1 here. So by doing that, then what we do here is change this positive 4 to a negative 4. Now this is where the biggest question comes from. Why a negative 4? Well, notice that we're changing our signs every single time. So basically, let me just change it up here. Instead of changing our signs, we're going to just do it once. So if I were to multiply by a negative 4, I'd just have to add. Now the next thing is I'm going to change my division sign to upside down. And then what I do is when you have this, like say y squared plus 12y plus 32, I'm just going to use the numbers here. So this is a 1, so I'll put a 1 here. Here's a 12, so 12 and 32. And to start off with, all I do is bring down the first number here, and that's your very first number that's going to work. And what I do here is I multiply this number times this number, which gives me negative 4, and I put it here. So I get negative 4, and I add that, which is 8. Now I take that number and multiply it by that again. So now I have negative 32, and my last value is 0. And notice that's the same thing that happened right there. And basically when you divide out, you reduce the power by 1. So my answer will be 1y plus 8. And notice that's the same thing as what we got up there, but much faster because we're not looking at the variables like y's and y squares. Okay. All right. So let's take a look at a couple more here. So you can see a pattern. All right. So let's say we want to divide out y plus 6 into y squared plus 9y plus 18. All right, so first off, like I said, there's going to be a 1 here all the time to start with. And it's just like completing square. If not, we divide it out, but we don't have to worry about that today. So first thing, change your signs. Create your division sign upside down. And now if there's a 1 here, put a 1 here. There's a 9 here, put a 9 here. 18 here, put an 18 here. Okay, and now we're ready to go. So first thing, carry down this number here, where it is, and take that and multiply it by that, negative 6. Now we don't have to subtract because we already changed our signs. That was a positive, so we just add, so it's 3. Now take that and multiply by that. That gives me negative 18. Again, which is a remainder of 0, so it goes into evenly. And I reduce the power down by 1, so therefore I have 1y plus 3. So again, what did I just do here? So I took y squared plus 9y plus 18 and divided by y plus 6. What does that mean? Well, that implies that this are factors of y plus 6 and y plus 3. So when I divide it out by y plus 6, it divided out and left me with y plus 3. Okay. All right. So now let's speed this up here. Do a few examples. Hopefully that gives you an idea of what's happening. Now let's just concentrate on the math part now. All right, so let's do something a lot bigger now. So let's say we have x minus 1, and we're divided into x cubed minus 4x squared plus x plus 2. All right, so let's start with change your signs. Positive 1. Flip up your long division upside down. So notice there's 1 there, so put a 1 there. Negative 4, put negative 4. 1 there, 1 there. 2, 2. And those two, you notice you have x cubed, x squared, x, and x to the 0. So if you're missing one, you have to put something in place of it, like a 0. All right, let's start it. Bring this down and multiply by that. 1. Add negative 3. Take that, re-multiply that, negative 3. Add negative 2. Take that, re-multiply by that again, negative 2. And the last one is always your remainder. So it went to evenly. And I reduced it by 1 power. So instead of x cubed, now it is x squared minus 3x minus 2. No remainder. If there was a remainder, I'll do one of those in a second here. You put that over x minus 1 with whatever your remainder is. But of course, in this case, there's 0, so we don't have to worry about it. Okay, let's try another one here. And speeding this up now. So let's say x plus 3. Divided out, you have 2x cubed plus 3x squared minus 8x plus 3. Okay, so change your signs. Minus 3. Upside down division. 2, 3, minus 8, and 3. Notice you also have x cubed, x squared, x to the first, x to the 0. You're not missing one. Again, if you're missing one, put a 0. All right, we're ready to start. So bring the first one down. Take that, multiply by that. Negative 6. Then you have negative 3. Multiply out. 9. 1. Multiply. 3. Again, remainder is 0. We reduced it by 1 power, so this is 2x squared. Because it was cubed, and we divided out an x. So we got 1 less. Minus 3x plus 1. And I said there's no remainder, so we don't have to worry about it. But if there was a number there, we put that number on top of x plus 3. But we don't have to worry about it. Okay? All right, let's try one more, and we'll call it quits after this. Okay, so if you want to, you might want to stop the video, see if you can do this next one once I get it written down. Okay. All right, like I said, you might want to stop it, see if you can do it. All right, hopefully you stop the video and see. So first off, change your signs. Upside division. You have 1, 1, 2, 2, 7, and 14. And again, double check you're not missing a power. You have x cubed, x squared, x, and x to the 0. So you don't have to put a 0 in one that's missing there. Okay, now we're ready to start. Bring down the first one. Multiply that by negative 2. That's 0. 0 times that is 0, is 7. 7 times that is negative 14. And it looks like, again, I got a remainder of 0. So one less power here. So this is 1x squared plus 0x plus 7. And I said there's no remainder, so I technically don't have to worry about it. So how would I write this problem? Well, I don't need that piece or that piece, so I just say x squared plus 7 would be my final answer. All right, so hopefully synthetic division looks promising to you. Good luck on your